Vinayak, Technical Director, Goyal Technochem Private Limited, to our esteemed audience.
Good afternoon, everyone. At the outset, I would like to thank IIF Chennai chapter for giving me the opportunity to introduce Mr. A.K Vinayak. He is a metallurgical engineer from Banaras Hindu University of 1972 branch. Presently associated with Goyal Group for more than 20 years. Associated with Foundry industry since 1972 and Foundry Chemicals from 1977. Has been visiting IFC, IFX since 1977 and has attended GIFA thrice in 1979, 1984 and 2023. He is known for his application knowledge and providing solution to Foundrymen. I request Mr. Vinayak to take the charge.
Welcome to all the Foundrymen gathered here. I would like to thank this IIF Southern Region and the organizers of the Foundry Day celebration Chennai chapter for giving us an opportunity to make this presentation that's in this forum. We are going to talk about something which will help the foundries achieve better castings without much of an extra cost to the foundryman. Today, the foundrymen are under pressure by the OE suppliers by their casting customers, to give excellent quality castings. They want very good finish. They want castings in time, not in time, on time. They want, if you don't supply on time, penalties are there. The rejections have to be very much controlled, especially at the machine shop. If the rejections are on the higher side, naturally the foundry is blacklisted, or there are certain penalties on that too. To meet these challenges, we from Goyal Technochem have done some R&D on the bentonites and the lustrous carbon to come out with a single premixed additive, which we call as PihBond series of our products. With PihBond, we have been able to, next slide. Okay, next slide. Yeah. So these are the demands of the casting customers, especially for green sand castings, that they want all these things without an extra cost to them. Next slide. With this PihBond, which has been introduced into the market about 6 years back, we have been able to show to the foundries, and the foundries have experienced this, that the overall cost, see, we are talking of a different concept altogether, not the price of the product, but the overall cost. That means the overall cost on the casting to the foundry, as compared to bentonite plus LCA system. How the overall cost with PihBond will work out? Because this is a purchase, the gentleman will naturally say no if the price is higher. But the foundry management, if the overall cost comes down and it advantages the foundry, definitely they would be more interested. There are a lot of technical benefits that PihBond will accrue to the foundry, and it's on account of this that the overall costs in the foundry will, if not be equal to, will be slightly lower than the bentonite plus LCA system. Next. The bentonite and LCA system per se, the sand per se, will be more expensive than the PihBond, than the the bentonite plus LCA system will be cheaper than the PihBond system, because the cost of PihBond is quite high. On account of the technical advantages that PihBond is able to offer to the foundries, this cost is not only taken care of, but it is also, but the foundry also gains, so that the overall cost of the system will be such that the foundry saves money. Now, what are these technical advantages that PihBond will accrue the foundry, and why these technical advantages are achieved? Next slide. See, PihBond is the same bentonite and lustrous carbon, but it is a judicious mixture of both processed Indian bentonite and imported bentonites, plus a very, very potent lustrous carbon. On account of its characteristics, it is able to impart very high strengths to the sand mix. Now, these things, these characteristics, why they are imparted is, number one, is shown in the next slide. Next. The retained activity, that is the thermal stability of PihBond. As you can see, at 500 degrees, maximum active clay in the prepared sand comes from the return sand. So the activity of the return sand is very important. It's our bentonite or PihBond is only a top-up addition of a very small quantity. So at 500 degrees centigrade, our Indian bentonite gives hardly 50% retained activity, whereas with PihBond it is 85%. At 550 degrees, 20 and 75, and at 600 degrees is hardly 5% and nearly 50% with PihBond. Next slide. Now, the sand parameters, effectively, with bentonite, the GCS is like this: 1130, sorry, 1100, 1400. The WTS 30 and 40, whereas the DCS goes from 5000 to 7500, which is an enormous jump, especially in the DCS. On account of these properties, after PihBond enriches the system, for maintaining the GCS, because any extra GCS is not required for the foundry, for maintaining the GCS, we necessarily have to reduce the quantity of PihBond addition. And this PihBond reduction doesn't depend only on the GCS, but our team who will be present during the enrichment period will look at the molds, will look at the condition of the mold, look at the condition of the castings, and accordingly they will decrease the additions of PihBond. The reduction in PihBond addition is considerable as compared to bentonite plus LCA. The lustrous carbon, as I said, that is used in PihBond is very, very potent. So in spite of the lowered addition, at the end of enrichment, once the system is deemed enriched with PihBond, the sand sticking to castings comes down drastically. We have got some videos and some photographs of castings before, pre and post PihBond. This is in a typical automotive foundry. These are the castings, sand sticking. You can see the amount of sand sticking has come down drastically. There is a video on the knockout where which shows video. Repeat पड़ेगा. At the knockout, you can see the sand sticking to the castings is hardly anything at all, which has been achieved because of after the enrichment with PihBond. Next. No, you've gone right to the beginning. क्या बात है? Yeah. Consequent to the reduction in the sand sticking to castings, naturally the short blasting time comes down, and the short blasting time comes down quite a lot. The reduction in this short blasting time will mean that the WIP in our casting cleaning yard becomes much lower than with what generally would be in the foundry using bentonite plus LCA. The time between pouring of the casting and its dispatch also reduces considerably, which means our invoicing cycle becomes shorter. Otherwise, so many castings are in the fettling yard awaiting dispatch. The whole scenario changes quite drastically after PihBond is introduced. The evidence of that is some photographs are there of the castings. Plus, one more thing that has been observed is that the surface grinding of castings to remove especially the sand which is sticking onto the castings very hard, that is not there, so which gives a lot of saving both in terms of time and money. This is the short blasted casting before PihBond and after PihBond. You can see there's a definite betterment in the short blasted. These castings had been short blasted for 4 minutes. These are some of the castings using PihBond that have been produced. So we have produced all types of castings in all types of lines, and the PihBond has worked for practically all the types of lines. So this is one video right from the short blasting. This is in a foundry where this 4 minutes of short blasting is done for this casting. Next slide, please. Right there. The sand-related rejections are also controlled. There is a downward trend in the sand-related rejections. The reasons for the sand-related rejections coming down are: number one, the fines in the system reduced drastically, because PihBond itself is a fine material. If we are reducing addition of that, the fines are reduced. Secondly, on account of the sand not sticking to the casting, the sand getting out of the system is very less. So with that, and the LOI of the system is reduced because of very low additions of PihBond. So both these points help in, one is it reduces the water demand of the system, and secondly it reduces the gas content in the system. So defects like pinholes and blowholes reduce considerably. The strengths which enhance like GCS, WTS and DCS also help in controlling defects like sand wash, sand drop, sand inclusion and scabbing. We have found especially scabbing has come down drastically after PihBond has been introduced into the system. Overall, with the enrichment of PihBond in the system, there has been quite a drastic reduction in the casting, in the sand related rejections, both at the foundry stage as well as at the machining stage. This has been experienced by the various foundries in which PihBond is running. There is also this mold breakage, mold damage. That also comes down considerably when using PihBond. This will improve the productivity of the foundry as well as it will reduce the sand wastage. So defects like this metal penetration. There was one particular foundry where metal penetration was very heavy, and we were given a challenge that you reduce the metal penetration, yes, then your material is okay. After about 1 or 2 months of PihBond introduction, of 2 months of PihBond introduction, now the metal penetration is more or less eliminated. I wouldn't say totally eliminated, but more or less eliminated. Next, please. Scabbing. This particular foundry had a endemic, nearly about 6% scabbing problems. That has been now they don't have any scabbing at all practically. Next. As it was explained previously in the previous slides, the DCS, that's the dry compression strength, increases drastically with PihBond introduction, even at the lowered addition rates. Now, when the metal enters the casting or the mold, the GCS has no role to play because moisture traveling happens. This phenomena happens, and because of that the GCS is just not evident. It is the dry compression strength that takes over. Since the dry compression strength is high with PihBond as compared to bentonite plus LCA, the swelling, the extent of swelling of the casting comes down drastically because the mold dilation is reduced. And to the extent of the lower mold swelling, lower casting swelling, you will have a weight reduction in the casting as compared to the bentonite plus LCA system. Again, the dimensional variation also is controlled because of the lower swelling of the castings. Is better controlled with PihBond than with bentonite plus LCA. New sand addition also comes down quite a lot with PihBond. Now, reasons for new sand addition, as every foundryman knows, one is sand sticking to the casting and getting out of the system, so topping up new sand is required. Oolitic formation is there, because of which you require new sand to counter that. So, in the case of PihBond enriched sand, one is the fines are going to be less, dead clay is reduced considerably, so oolitic formation taking place is hardly there at all. Again, the top-up sand required, because your sand is retained in the system, since the sand sticking to castings is hardly there, so you don't require that much of sand to top up. Only for adjustment of the final AFS of our prepared sand, the new sand addition will be required. Okay, to some extent, some sand definitely goes out with the casting, so that much will be required further. But mainly it is for adjustment of the AFS. There are a few foundries, we have had the experience there, where new sand is zero, provided the core sand that gets in, infiltration of core sand, is supporting the AFS of the molding sand. If that happens, then and enough of coarse sand is getting in, the nil new sand addition, new molding sand addition has also been recorded and is being used. Now the extent of effect of PihBond. As compared to bentonite and LCA system, depending on a lot of number of factors, the addition of PihBond is reduced between 30, although I've given 45% here. There have been cases where even 55% reduction has been achieved. And here the GCS etc. has not gone up, not down. Addition of new molding sand to the prepared sand down by 50%, definitely. Sand sticking to castings reduced minimum by 30% as compared to the pre-PihBond usage. Short blasting time, minimum 25% reduction in short blasting time in practically every foundry that we have introduced PihBond has been achieved. So foundry stage rejection, we say around 20%. There have been cases where much higher reductions have been achieved. It depends on the controls that the foundry can exercise. But definitely minimum 20 to 25% definitely will be there. By a similar logic, the machining rejection also, which are sand related, that also will evidently come down. Pinholes and blowholes and things like sand inclusion, etc. Weight of casting. The weight reduction in casting depends quite a lot on the molding line and the controls that the foundry can exercise. Generally what we have found is for vertically parted and KW lines where the pressures are very high and controls are definitely supposed to be better, there is about 0.75% in the reduction of weight of castings. In horizontally parted high pressure lines, other lines, it is between 1 and 1.25%. And in the Joule squeeze line, 1.5 to 2.5% have been achieved. In fact, in Joule squeeze lines, even much higher have been achieved, but we don't want to claim that. These things are based on our experience with the various foundries where PihBond has been introduced and is running. The surface finish of the casting also improves considerably. This is without touching the AFS of the sand. This is because of, number one, the fines are reduced, moisture demand comes down. When both these come down, the flowability of the sand increases drastically. When the flowability increases, the compactness of the mold goes up considerably. So the surface of the mold which is presented to the metal becomes smoother than previously, and that ensures a better finish to the casting. Yeah. The effect on sand. After PihBond enrichment is complete, the reduction of LOI is to the tune of nearly 20%, sometimes even more. But even with this reduced LOI, the sand sticking reduction is very good. The active clay will be retained more or less as whatever the previous level was, but with lower addition of PihBond. Total clay will be reduced by about nearly 25%. Moisture demand in the sand will go down by at least about 8 to 10%, in some cases much higher. WTS and GCS will be sustained or marginally increased. We are doing that because we have reduced the amount of PihBond getting in, but the DCS will increase minimum by 25%. Next, yeah. Then effect on commercials. With PihBond enriched sand, even at lower additions, the cost of the sand is higher than that of bentonite plus LCA after the enrichment is complete. But because of the overall cost, if you consider, taking into consideration the cost of all the tangible advantages that have been shown here, the effective overall cost comes lower than with the PihBond, with bentonite plus LCA system. This the foundries have experienced, which is why we are today in position to manufacture and supply more than 2,000 tons of this material to more than about 100 foundries all over the country, including some prestigious foundries. There are a number of intangible benefits in this also with PihBond. Like waste sand production is reduced completely. Not that any foundry wants to produce this waste sand, but okay, it happens. It's a byproduct, but that comes down drastically. So this also the fines that are generated are less. So the pollution in the foundry is reduced, plus dumping costs are reduced. Lower WIP after casting is poured. See, WIP costs money. If you are holding lower WIP, or definitely there is some cost added there. Reduction in invoicing cycle. So that is also an advantage to the foundry. Conservation of scarce raw materials like raw sand, raw molding sand, and bentonite, etc., which are mined. So we are conserving that because the addition has come down by nearly 30-40%. Ease of operations and handling. The control of PihBond is a single additive, so you have to handle only one additive. You have to control only one additive, and here we find that in general, if you are able to maintain the active clay to the required levels, the alloy gets adjusted by itself, and you have absolutely no problems in the foundry. So the ease of operation is also very important. So this, if some of these we call it as intangible advantages, which we are not able to calculate by ourselves, if the foundry gives some values to that, the savings that a foundry can get will be definitely much higher. Next slide. Yeah. In conclusion, we can say that the various advantages that the premix single additive for green sand has to offer is definitely a solution to the demands that the casting customers are making of the foundry. Here you are getting a better finish, your rejections are coming down, your sand is getting better conditioned, and so in general the cost, these advantages you are getting without increasing the cost much, or even in most of the cases there is some saving to the foundry. So as such, this is definitely an innovative way that we can help the foundry to achieve their final goal. So once again, I want to thank you for the patient listening you have given me. Sorry, there have been a little bit of a problem because of the video not coming on at the proper time. So if there are any questions or any queries, we'll be only too glad to take it up.
Thank you, sir. Any questions?
The differential housing of sonolic attractors. So have you studied any warpage different after implementation of your P code?
Yeah, the dimensional accuracies and warpages have definitely come down. One of the things I will tell you, in one particular number of foundries where brake drums are being produced, okay, they were getting this ovality problem. With PihBond usage, this ovality problem has not, I wouldn't say it has been eliminated. It has been reduced considerably to this extent that these people, they are using jode squeeze machines, okay? They were able to load on to machining something like about 45 castings or 48 castings per shift. Not per shift, per day, I'm sorry, per day. After PihBond was introduced there, they have been able to go to nearly 76 or 78 castings per day. So the ovality part of it has come down drastically. And as far as warpage is concerned, definitely this, because of its higher strength both in the form of GCS as well as the DCS, the warpage will definitely reduce.
Okay. Because major concern is uniform machining elements required when you are doing big castings.
Yes, this has helped. Yeah.
Thank you, sir. Thank you.
You're welcome.
Any more questions? For your excellent presentation.
Thank you.
We extend a request to Mr. Balamurugan, Chapter Council Member, to felicitate Vinayak sir with a traditional Angavastram. We now invite Mr. K. Balasubramaniam, past SR Chairman, to present a memento to our esteemed speaker. Thank you, sir.